Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello everybody. Welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and as always, welcome to the podcast. Today's episode, we are going to talk about a controversial topic. What is that? Well, arc fault circuit interrupter. Boy, that's always a controversial topic, right? Depending on where you're at in the country, some people are amending them out of the code. Some people are fully behind them. Obviously, the NFPA is fully behind it. The fire marshals are fully behind it. Inspectors are fully behind it. But, you know, sometimes those home builders, they just don't like it. It raises the cost of construction. Of course, so does that granite countertop and everything else that gets added in there, like the audio, visual, and everything else. But, of course, those are selective. You get to choose them, and people like to say that 210.12 of the NEC is a mandating it or forcing it down people's throat. But anyway, whatever side of the fence you happen to be on, okay, the reality is AFCIs are here to stay. They're not really going anywhere. Of course, if they were going somewhere, then you'd be a part of the process. And in order to get anything removed from the National Electrical Code, one, you're going to have to justify it. And there's enough data that shows that arc fault circuit interrupters work. It just might not be something that you've experienced, but there are cases out there. You can search for them. They're all over the internet. I have some personal experiences where I have seen them work in one of our company's installs years ago, back in Virginia when it was only in the bedrooms. Of course, it's still only in the bedrooms circuit for Virginia. But anyway, so today I figured we'd take the opportunity to look at 210.12 of the National Electrical Code and break it down a little bit. Okay, and it makes it a little easier for people to understand it. Now, granted, we're in 210.12, and you'll have there's an A and there's a B. Of course, you do have C, which is new for the 2017 code, which is guest rooms and guest suites. And, of course, you have D, which is extensions and things like that. So we'll briefly cover all of those aspects of it. But we want to talk about it, and we're dealing with the dwelling unit. Okay, that's the key focus that we're dealing with right now. We're dealing with dwelling units. That's the key charge in 210.12a. So let's kind of look at it now. Again, what are arc fault circuit interrupters? Generally, what they're doing is trying to disrupt an arcing characteristic, whether it's a parallel or series. And if you think about the difference in the two, that's what a combination AFCI is. And there's a lot of people out there that hear the term combination AFCI, and they immediately think that we're talking AFCI, arc fault protection, or detection, and then they're thinking GFCI, ground fault circuit interrupters. And there are two different things. Those are dual functions. If you get a device that does AFCI and GFCI, that's called dual function. You don't call them combination. A combination AFCI is really looking for the characteristics between a parallel and a series arc. And kind of give you a broad understanding of what we're talking about here. A parallel arc is if you take your two fingers, your two pointer fingers, you take your two like you're pointing at somebody. You take from left hand and right hand pointing at somebody, and you point both of them at somebody. It's the arc that can go from the one finger over to the other finger. I mean, I'm using a dramatic way of describing it. If you know cables, for example, if you take an NMB, which is a non-metallic sheath cable, it typically has a black conductor in there and a white conductor in there and then a bare equipment grounded conductor in there. It's the arc that can take place between the white in the black conductor, okay? That's typically a parallel type of arc that can take place, okay? And so when you're dealing with things like extension cords and other things that go through door jams, that doors could slam on them, they potentially could damage both conductors, creating an arc across those points. And that's a parallel, okay? And that is not really dependent on the load because it's simply an arc that takes place across two conductors that can create its load depending on its distance, proximity, what's going on. And the other one is a series arc. Now, a series arc is kind of taking those same two pointer fingers and then turning them and touching them end to end. So it's actually a conductor that has a break in the conductor or is a loose termination, let's say, at a device. And over time, you don't torque it right or do something. And over time, you got this arc that builds up, and it's very load dependent. Okay, it really not going to have current flowing through that arc point or that point of contact unless you have some load in order to generate this arc to go across these two close contact points that are broken. All right, so a very, very poor connection when it comes to the series. Now, each one of them had their own characteristics that are tested under the UL standard, UL 1699, and they have to meet all these tests in order to be able to qualify as an arc fault circuit interrupter. They're available today, whether it's in the type that's for the branch circuit only, which is a receptacle that goes all the way at the first receptacle location. And it's called a branch circuit over. Actually, the fundamental name is called the outlet branch circuit type AFCI, and that goes at the first outlet generally. And you'll see what we talk about here in a second. And of course, then you have the ones that go into the panel board. It connects onto the panel board inside of an enclosure. So two different types. You can get the combination rating in both. But when you hear combination, you have to remember what we're talking about in combination in both is distinctively trying to achieve the aspect of both a parallel and a series protection. Okay, so that's the fundamental thing to remember is that's what a combination is. Now, we have things called a listed branch feeder type AFCI, which actually went out of the NEC and then came back into the NEC because the code required for it to be a combination, but that really didn't have a really good firm location for these listed branch feeder type AFCIs because they only offer one type of protection. All right, so and so they were very, very limited, and they offered parallel protection, but didn't really offer series protection. Okay, so we now see that in the 2017, and it came back in the really came back in the 14. Is we now see a complete list of all the options for AFCI protection, understanding that we're talking about protection of the branch circuit here. Okay, that's what we're generally talking about, and we'll show you how to define that when you look at it. So let's go on and jump into it. We'll kind of cover. But incidentally, like I said, a listed branch feeder type offers parallel only protection and doesn't really offer series protection. Of course, you do have some caveats on how you install it, but we'll look at all those options here. And I'll tell you ones that are available and ones that are not. All right, let's look at it. 210.12 arc fault circuit interrupter protection. It says arc fault circuit interrupter protection shall be provided as required in 210.12 A, B, and C. It also reminds us that the arc fault circuit interrupter shall be installed in a readily accessible location. Very similar to what you see in 210.8 for GFCIs. Got to be readily accessible so they can be tested frequently. They have a test button on them. You test them out, make sure everything's going good. If they have to be reset, you have to be able to get to them. Again, there's a difference between accessible and readily accessible. We know the definition of that by going to Article 100, and we can read the definition of readily accessible, and we understand it has to be able to reach to quickly without having to climb over, climb under, moving. Anything obstructs its be able to get to it, then that would not be readily accessible. Okay, sub-item A, which is the dwelling units. Okay, so firmly dealing with dwelling units here. It says all 120 volt. Now here's a tip for people. When you see 120, you know you're talking about the whole circuit. Okay, if I saw 125 here, it's kind of denotes a NEMA rating, and that would be like a device. So it's a little tip for you. If you're navigating something in the code and you want to know whether it's talking about the whole circuit or whether it's just talking about something that has to do with the receptacle componentry involved in it, then you might see 125 there because that's a NEMA rating for device. All right, it says all 120 volt single phase. Okay, so we're dealing with single phase. Just remind you that single phase can be derived from three phase. Very typical in a multifamily dwelling type of concept where you might have a three phase, and then you have the A and C derived, and you'll have a center tap in order, you'll come off of it. So it's three phase, which actually results in a single phase, depending on how the configuration is. So just keep that in mind. But here we're talking single phase. You'll know that if you test any of the lines to ground, you get 120 volts. That's a key because it's only dealing with 120 volt. So if you're testing with your voltmeter, you know that you've got a single phase. If you do any of the lines to ground, 120, you're good to go. All right, so or to neutral. All right, so 15 and 20 ampere branch circuits. So that's only dealing with 15 and 20 ampere branch circuits, supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, or similar rooms or areas shall be protected by any of the means described in 210.12a1 through 6. So we have 6 options here. The only thing I will point out is when you see the supplying outlets, that doesn't necessarily mean receptacle outlets alone. Okay, lighting outlets, receptacle outlets, outlets for smoke alarms if they're in there. Things like that. Oh, incidentally, difference between a smoke alarm and a smoke detector is a smoke detector usually connects to a central monitoring system, and a smoke alarm is what you'd see in a 1 and 2 family dwelling or something where it's actually audible and it's powered all at the same time. So everything's, it's a completed unit type of thing rather than just something that's connected back to a central monitoring system. That would be what you'd see in larger complexes, and that would be, smoke detectors. We're talking about smoke alarms, that type of thing. So if you have the outlet that derives the power from that outlet to that device, or to that, the outlet, which has utilization equipment connected to it, then of course that's an outlet. Okay, so just kind of keep that in mind. So when you see outlets, you're not thinking just receptacle outlet. I'm pretty sure we all know that, but that's kind of good to remind people. Number 1, it says a listed combination type arc fault circuit interrupter installed to provide protection of the entire branch circuit. Okay, so we know what that one is. We talked about what a combination is. It has both parallel and series protection. Combination does not mean AFCI, GFCI. Okay, a little reminder that 210.8 does require the GFCI protection, and you see that kitchens was listed up here. There are occasions where you're going to have both GFCI and AFCI protections that's required. Yes, I can have an AFCI outlet, as you'll see here in a little bit. I could have that option, and I could have a GFCI there and then have the AFCI back in the panel. Whatever combination works, they both work fine together. I could have a dual function AFCI device, which also provides GFCI protection. And so if that's the case, remember, that's dual function. That is not a combination type. The combination type, which will be marked on your breaker, is designed to detect parallel and series arcs. Okay, there's a difference. All right, so I can put a combination type in there and protect the entire circuit. I'm good to go. So item 1 is the easiest way to achieve, right? Just go buy the breaker. All right, what about item 2? Well, what if I still have some of those branch feeder type AFCIs? Okay, then I can use them. And they're listed, obviously listed to be from the manufacturers. Eaton makes some, Square D makes them, or Schneider. Siemens makes them. All of the manufacturers will typically make one of the branch feeder type AFCIs as well. They stopped making them, a lot of them, when they started coming out with the combination requirement. But if you get your hand on some listed branch feeder, and it'll say that right on the breaker, okay, the AFCI breaker, okay, if it says that, then you can use those. But there's a caveat to that. It says a listed branch feeder type AFCI installed at the origin, okay, at the origin of the branch circuit in combination with a listed outlet branch circuit type arc fault circuit interrupter. So there you start to see those outlet branch circuit. And they look just like a GFCI receptacle that you would have in the kitchen. You're probably familiar with them in the bathrooms. They look very similar. And in fact, if you didn't know any better, you probably would just look at them and think it was a GFCI device. But they look very similar. But they are called, we generally will refer to them as OBC, but they're listed outlet branch circuit arc fault interrupters. Now, if you want to have a branch feeder AFCI at the panel, at the origin, that's where it originates, and you put this, and now it gives you the caveat. It says, well, if you're going to use this listed outlet branch circuit type arc fault circuit interrupter installed at the first outlet on the branch circuit, so wherever you're coming from the panel, and then you feed it, at that point, you're going to have the parallel protection and you're going to get some series protection in combination, and so you're going to try to achieve everything with these 2 units. All right? It says the first outlet box in the branch circuit shall be marked to indicate that it is the first outlet in the circuit. So hopefully you've laid that out. You know what you're doing. That's the very first one, and you're going to put it in there. And, of course, you have your listed branch feeder type back at the source or the origin of the branch circuit. Again, the branch feeder is not going to provide both parallel and series protection. That you need it in combination with a listed branch circuit type, listed outlet type branch circuit AFCI device. Okay, so both of those in combination. The next one is item 3, which tends to be the most confusing for people. I will tell you up front, I am not aware of any listed supplemental arc protection circuit breaker that would generally be installed in a residential type panel board. Now, there might be some out there, I don't know. But for the inspectors, you're simply going to verify, if this is the method they're using, you're simply going to verify that it states on it, because it's listed, that it says supplemental arc protection. Now, why would you do this? When you have probably, because you're still going to end up buying a outlet branch circuit type AFCI anyway, okay? But there is an option in here. Of course, it has caveats to it. So if you find a listed supplemental arc protection circuit breaker, if you can find one, if they were out there, and maybe by the time this gets to the air, somebody's come out with one. But I'm not aware of any to date. And not to complicate the issue, it was exactly what it sounds. It's simply designed for supplemental arc protection. Okay? So if you find it, it says, okay, you can use a listed supplemental arc protection circuit breaker. It's a specialized circuit breaker. And you put this at the origin of the branch circuit in combination, again, with a listed outlet branch circuit type arc fault circuit interrupter installed at the first outlet box on the branch circuit where all of the following conditions are met. Now, up front, I'm going to tell you, you're probably not going to find one. So you're better off, if you got to do all this anyway, without the limitations, you're better off to jump up and use item 2 and just get a listed branch feeder type, and then put one in the first a branch circuit type outlet AFCI at the first outlet, because you got to go through all these little hoops to get to it here in a second. I might as well go with option 1 or option 2. I mean, it's probably at this point, it's probably just cheaper to get a combination type AFCI. But anyway, you do have some options. So let's say you find a listed supplemental arc protection. Good luck if you can find one. But if you can, you got some caveats here. All right, let's say I get that supplemental arc protection circuit breaker. I find one. And I go out and I purchase me a listed outlet branch circuit type AFCI. Looks like a GFCI. Goes in the first receptacle. Okay, first outlet box. What do I got to do? Well, first thing here, it says the branch circuit wiring shall be continuous from the branch circuit overcurrent device to the outlet branch circuit arc fault circuit interrupter. Okay, so really the wording here should say, be honest with you, it should say the branch circuit wiring shall be continuous from the listed supplemental arc protection circuit breaker to the outlet branch circuit arc fault circuit interrupter. Okay, because that's kind of misleading, because branch circuit outlet device, overcurrent device, is a standard overcurrent device. Okay, so I'm not sure I like how that's worded, but it is what it is. Okay, second, it says the maximum length of the branch circuit wiring from the branch circuit overcurrent device, which ultimately sounds to me like is the actual listed supplemental arc protection circuit breaker, okay, unless somebody tells me otherwise, that length of that branch circuit device to the first outlet shall not exceed 50 feet if you're using 14 AWG conductors, or 70 feet for 12 AWG conductors. Okay, so this could be a non-metallic sheath cable, whatever. Only thing you need to focus on is the size of the conductors that are the branch circuit wiring. Okay, that's what you need to focus on. So in residential, this would be typically non-metallic type of products, like something like an NMB or what have you, that you would look for something like this. So you're going to have limited lengths. Okay. And then lastly, it says the first outlet box in the branch circuit shall be marked to indicate this is the first outlet in the circuit. So if you have to go through all these hoops with these limitations, be honest with you, I'd rather probably do item 1 or item 2, and I have no length limitations. And they're probably going to cost me more for a listed supplemental arc protection circuit breaker, which is not going to be used, and it's all about supply and demand. So not so sure I would use a listed supplemental arc protection circuit breaker. They're going to be a rare oddity. I guess it's a race to see who's the first one to come out with one, I guess. But why would you do it? That's opinions now. I'm giving you an opinion. I don't want anybody to go sending me nasty hate mail, especially the manufacturers sending me nasty hate mail saying, oh, no, we do have one and they cost cheap. Whatever. Not sure I agree, but we'll go on. Okay, so that's your third option. And that's, again, for a supplemental arc protection circuit breaker in conjunction with an outlet branch circuit, OBC, outlet branch circuit arc fault circuit interrupter device placed at the first outlet. Okay, a lot of stuff to jump through for item 3. I think we tried to get this one removed from the code, but of course, manufacturers love options, and so this is just another option that allows them to be able to produce it. But again, I haven't seen any. All right, let's go to item number 4. This was a bit of an oddity as well. It says a listed outlet branch circuit type arc fault circuit interrupter installed at the first outlet of the branch circuit. Okay, so that's those little devices that look like GFCIs. Okay, they are not GFCIs, but they look like GFCIs. And it says with a listed branch circuit overcurrent device. So that, to me, that's a standard branch circuit overcurrent protected device. Okay, 15 amp, 20 amp. It's a standard circuit breaker, in my mind, that's kind of what we're talking about. And I like to keep it as circuit breaker because it's easy for you to understand. But that's what we're talking about. It says where all the following conditions are met. So this is going to allow me to have a regular circuit breaker in the panel, and I can have at the first outlet. Okay, I got to have one of those outlet branch circuit type. Looks like a GFCI, but it's an AFCI device. But I got to meet all these caveats to be able to use a standard circuit breaker with one of these arc fault outlet type AFCI devices. And it needs to meet all these rules. Number 1, it says the branch circuits shall be continuous from the branch circuit overcurrent device. Now that is accurate wording. I don't like the wording in item 3. We need to fix that. But I like the wording here. Branch circuit wiring shall be continuous from the branch circuit overcurrent device to the outlet branch circuit arc fault circuit interrupter. Okay. We get it. From the panel right to the first box. No breaks. Okay. Continuous. That type of thing. All right. So we got it. Okay. We're not going to get into the continuous in the definition of continuous and whatever, through splices. We'll leave that for another day. There's no way I'm going to make this more confusing than it is. All right. So continuous. In other words, it really needs to go from the panel to this first box. Okay. Second, it says the maximum length of the branch circuit wiring from the branch circuit overcurrent device to the first outlet shall not exceed 50 feet if it's 14 gauge conductors, or 70 feet if it's 12 gauge. Okay, sound familiar? Okay, nothing's changed there. Item number 3, which is actually C. Okay, it says the first outlet box in a branch circuit shall be marked to indicate that it is the first outlet on a branch circuit. So again, or the first outlet in the circuit. Kind of like, we put the little label there that tells you, hey, this is the first outlet. Okay, this is it. And of course, that's where we're going to put that AFCI outlet, that device at. That's where we're going to put it. We're going to put it right there in that first one. And then the fourth thing, or D, they have listed here in the code, says the combination of a branch circuit overcurrent device. Now, here's the part that's hard for the manufacturer to meet, unless they happen to be a manufacturer that owns both the manufacturing of circuit breakers and the manufacturing of AFCI outlets devices. Okay, if they make both, then this is easy to achieve. But here's the caveat to meet this whole out. Everything sounds good, right? I can have a regular breaker and I can have one of these OBCs in the first outlet. Everything sounds good until you get to this one. And it says a combination of the branch circuit overcurrent device and the outlet branch circuit AFCI shall be identified as meeting the requirements for a system combination type AFCI and shall be listed as such. Boy, that's the hardest part to achieve here. It has to be listed as such. So in order to do this, I have to make sure that my circuit breaker, we'll use circuit breakers for simplicity here, circuit breaker is listed, okay, to work with this outlet branch circuit AFCI together as a combination. Now, getting these manufacturers to play together and come up with a listed combination between the circuit breaker, it's almost one of those cases where it's only going to be available to a manufacturer who's willing to go out and test all of their breakers, standard breakers, in combination with all the options out there for the outlet branch circuit AFCIs. And they have to test them, and they're going to have to get them listed to it. So it's kind of like, it sounds like a classified situation, like where we have a classified breaker that can be used in many other type of panel boards and other enclosures because it's been evaluated and tested and listed. Sounds like something's got to go on here. So to inspectors, if this is the one that's being used, remember, it has to be listed as a system combination to work with that circuit breaker, okay, that overcurrent, that branch circuit overcurrent device, with that outlet branch circuit AFCI. They have to be listed as a combination system. And that's the hardest part to achieve. Okay, so check them. Make sure you see them. It's not a given. Just because you see a breaker there and the same manufacturer might own a company that makes the OBC AFCI device out in a receptacle, out in the first outlet, does not necessarily mean they're a system combination. So you don't simply take that for granted. Okay, just kind of giving you the skinny on that. Item number 5 says, all right, look, if it's RMC, that's rigid metal conduit, IMC, intermediate metal conduit, EMT, electrometallic tubing, remember EMT is a tubing, not a conduit, type MC, we got to love it, that's metal clad cable, or, oh, incidentally, when it says type MC, it doesn't matter whether it's aluminum or steel in this application. It's not stating that. And then it says, or steel armored type AC. So that what it is stating, it has to be steel armored AC. Okay. Meeting the requirements of 250.118. Of course, 250.118 is telling us what meets the requirements to be an equipment grounding conductor, and all those can. Of course, in 250.118 MC, the MC itself, the armor does not meet that requirement, but MC itself does require that it has an equipment grounding conductor installed inside of it. Okay, so we're kind of meeting all those rules there. It also goes on to say metal wireways, metal auxiliary gutters, and metal outlet and junction boxes are installed for the portion of the branch circuit between the branch circuit overcurrent device, okay, back at the panel, and the first outlet. Okay, so if I'm using RMC, IMC, EMT, MC, or a steel armored AC, and all of those that have the caveats to make them meet 250.118, that is qualifying as an equipment grounding conductor or has an equipment grounding conductor in it. And also, if I happen to choose the option to use between point A and point B, A being the breaker and B being the outlet, the first outlet, that if I have a metal wireway, metal auxiliary gutter, I have a metal outlet and junction boxes are installed for that portion of the branch circuit between the branch circuit overcurrent device and the first outlet. If that's all done, and I've used it, in other words, the key trigger here is metal, 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 everything's metal, it shall be permitted to install a listed outlet branch circuit type AFCI at the first outlet to provide protection for the remaining portion of the branch circuit. Okay? So, up to that point, I have all this metal type of wiring methods. And then in metal junction box is the first outlet. It's a metal, okay, in metal outlet box. All this is metal, 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 all the way to the point. It seems to say that after that, the outlet branch circuit device actually. So I'm sorry. The recap here. So everything up to this point is metal, and so after this point, is really doesn't. At that point, it can be NMB, whatever you want, whatever wiring method chapter 3 that's applicable to the installation. So up to that first outlet box, which is metal, it shall be permitted to install a listed outlet branch circuit type AFCI at the first outlet, and that again provides protection for the remaining portion of the branch circuit. We have no length limitations here under that one, like you do in option 3 or in option 4. So okay, so there you go. I actually know installers who it could be even, they will actually install the MC even in a project that's going to use non-metallic sheath cable just to, maybe meet this rule, and they'll put that first box as metal, and they'll do this here, and this gives them an option. Again, if they do this, then they can use a regular circuit breaker. And at that point, they can just put an outlet style AFCI in for that. That's an option for them. Probably costs very similar to the breaker anyway, combination. So, not always an option for you, but I mean, there you go. You got an option. You got a potential option. And then item number 6 says, okay, where a listed metal or non-metallic conduit or tubing, okay, or type MC cable is encased. Now remember, if it's MC cable and it's encased, and it's going to PVC jacketed type. Just kind of throw that out there. It says where they're encased in not less than 2 inches of concrete for the portion of the branch circuit between the branch circuit overcurrent device and the first outlet, it shall be permitted to install a listed outlet branch circuit type AFCI at the first outlet to provide protection for the remaining portion of the branch circuit. No length limitations here set on that. It just telling you that, hey, the first part of it from the panel all the way to the first outlet box has to be listed metal or non-metallic conduit or tubing or type MC cable is encased in not less than 2 inches of concrete for the portion of the branch circuit between blah, blah, blah. Okay. The real ruling of this is that we're talking encasement all the way on that entire branch circuit, encasement from the panel all the way to the first outlet. Very hard to achieve. We're not talking about stubbing it down the wall or stubbing it down and then going into concrete. The way this reads, again, if you read it slowly, it says where a listed metal or non-metallic conduit or tubing or type MC cable is encased in not less than 2 inches of concrete for the portion of the branch circuit between the branch circuit overcurrent device and the first outlet, it shall be permitted to install a listed outlet branch circuit type AFCI at the first outlet to provide protection for the remaining portion of the branch circuit. Okay? So, that rule is, you have to really slow down and read that one. Now, because, what we're trying to do here is it's about the protection. So, in this case, the concrete provides that protection, that 2 inches encasement provides that. Okay? And that's really protecting the portion that's the branch circuit all the way to the first point on the outlet where that outlet type AFCI is installed. Okay? All right. So those are your options for the to be able to do the applications here as it is in the NEC. And you have those 6 different options. Of the options, again, as a recap, 1, use a combination type AFCI device, which could also, the combination is parallel and series arc detection. And that's can be your circuit breaker, obviously, is what's going to be the combination type, and you install that in a panel. So you do that. You have option 2, which means you could use the listed branch feeder type that only offers parallel, not series protection. However, you have to use it in conjunction at the first outlet. You have to use an OBC, outlet branch circuit type AFCI device, and you use those in conjunction. There is no length limitation on that. It's just using those together in conjunction. Item 3, which is listed supplemental arc protection, they're not really available, but if you do, you have to meet all these caveats. 50-foot length limitation for 14 conductors, 70 feet for 12. Still has to be an OBC device, has to be installed in the first outlet box of the branch circuit. Okay, and the branch circuit has to be continuous from the overcurrent protected device to the first outlet. Okay, then you got item 4, illicit outlet branch circuit type. Again, you can use that. The listed outlet branch circuit type shall be used in the first outlet of the branch circuit with a listed branch circuit overcurrent device. It's a standard overcurrent device, but you have to meet all the caveats. And again, at the end, the one that's trickiest to meet is it has to be identified as a system combination with the circuit breaker matched with the outlet branch circuit AFCI. Not aware of any of those out on the market. Next, if you have a RMC, IMC, EMT, type MC, all of those qualify as equipment grounded conductors in 250.118. Or if you have a steel armored type AC cable, it incidentally does qualify in 250.118 as a equipment grounded conductor. But also if you use metal wire ways, metal auxiliary gutters, and you have to have metal outlet box or any junction box are installed for that portion of the branch circuit between the overcurrent device and the actual first outlet, then everything has to be metal, in that caveat there. It shall be permitted to install a listed branch circuit type AFCI at the first outlet to provide protection of the remaining portion of the branch circuit. Again, everything's in metal. Everything has a ability to have equipment grounding conductor or meet those qualifications or what have you. So we're good to go there. But you do have this afforded protection. And then you also have another protection method, which is for the actual protection of the wiring between the overcurrent device and the actual first outlet, is that you could take metal or non-metallic conduit or tubing or even type MC cable, and if it's encased in not less than 2 inches of concrete for the portion of the branch circuit between the branch circuit overcurrent device and the first outlet, then that's considered protected. It's in concrete. It's not subject to any physical damage at that point because it is protected. Then once you get to that first outlet, you put an AFCI type outlet device there, and then of course that protects the remainder of the branch circuit. There's no length limitations on it like you do with the others with item 4 or item 3. Okay, both again, item 3 and item 4, I don't believe there's anybody out there that can meet those allowances. So you're pretty much stuck with use of option 1, 2, and 5 and 6. Those are your options. Now, you do have an exception. The exception says where an individual branch circuit to a fire alarm system installed in accordance with 760.41b or 760.121b, again, dealing with obviously 760, so it has something to do with fire alarm systems, and it's installed in RMC, IMC, EMT, or steel sheathed cable, type AC or MC, meeting the requirements of 250.118, so it's got to meet all the requirements of that. Again, 250.118 is dealing with what's be considered an equipment grounding conductor. And it says, with a metal outlet or junction box, AFCI protection shall be permitted to be omitted. So if you want to put it on it, it's fine, but you can omit it for those circuits as long as you meet this caveat here in this exception. Okay? There's some good informational notes here that remind you where we get the information about AFCIs and the how to know the difference between a combination type and a branch feeder type AFCI. All that's good information under UL 1699. Great stuff for that. There's also a 1699A, which is actually the outline of investigation for those branch circuit outlet type AFCIs. So pretty good information here. Okay. Now, item B here is as dormitory units. Slightly changes here into it is, again, all 120 volt single phase 15 to 20 ampere branch circuits supplying outlets and devices. Okay. When we see the and devices, we're talking switches, all those applications, the branch circuit that's supplying those as well now come into play. There was an argument that devices wasn't a trigger and it only had to do with outlets, but they added the term devices to make it very clear that devices that are on that circuit also qualify. So outlets or devices, okay, installed in dormitory unit bedrooms, living rooms, hallways, closets, bathrooms, and similar rooms. Love the similar room statement. That's up to the HJ to make that determination. If walks and talks and smells like a hallway, a living room, or whatever, then that gives them a little bit of their leeway to be able to classify what that is. Shall be protected by any of the means described in 210.12A1 through A6. Okay. Then you have a new one, guest rooms and guest suites. A little different, obviously, than dormitory units. The guest room and guest suites typically deal with hotels and motels. And here it's new. It says all 120 volt single phase 15 to 20 amp branch circuits supplying outlets and devices installed in guest rooms and guest suites of hotels and motels shall be protected by any of the means described again in A1 through A6 of 210.12. Okay, so again, you're dealing with any guest rooms and guest suites. There you go. One interesting thing about this is it's item C, and this is not dependent on being a dwelling unit. This is simply classification of guest room, guest suites for hotels and motels. Okay, nothing in there about having it have to be a dwelling unit, have to have all the elements of a dwelling unit. Okay, it's simply guest room and guest suites of a hotel and motel are required to meet this application here. Then you get it to D, the last one we're going to talk about today. Again, this deals with dwelling units and dormitory units, so this is very specific to that. It says branch circuit extensions or modifications. So again, we're talking about any change, modification to the branch circuit itself. This is or extending an existing branch circuit could trigger this requirement. It says, in any of the areas specified in 210.12a or b, and again, A was your dwelling unit applications, and B was your dormitory units, okay? That's hence the name of D, the title in here in the charging statement. Now, it says, in any of the areas specified in 210.12a or b, where branch circuit wiring is modified, it's replaced, or extended, the branch circuit shall be protected by one of the following. Okay, so we're now talking about the branch circuit extension or modification, and we're going to have a list here. Number one, it says, well, what are my options here? The first one is a listed combination type AFCI located at the origin of the branch circuit. Again, it's kind of like the option we have in the 210.12a for the dwelling unit. We have that option. Okay. All right. So then it goes on and says, well, what are the second option? And we only get two options here. The second one says, well, a listed outlet branch circuit type AFCI located at the first receptacle outlet of the existing branch circuit. Okay, so if I want to modify it, I want to lengthen it, I want to change it. Okay, if I replace it, everything, it looks like my option is going to be option one. Okay, if I'm going to take an existing branch circuit, I'm going to extend it, maybe to hit another receptacle or whatever. Maybe it's a period of time where it didn't meet all the 210.52 spacing rules, and you're doing some kind of modification, and somebody's come in and they want to extend it now, and it's perfectly fine. Well, they have these options here, and one of the options is well, I'll let you use a listed outlet branch circuit type AFCI located at the first receptacle outlet of the existing branch circuit, and that is an option. So I can meet one of the following. So if I did that extension, yes, I could go back and put a listed combination back at the original panel, but there's a good chance that if this is an older system, that I might not have the ability to put one at the origin. They might not make a breaker that is actually a combination type that is listed for use in that existing panel. So I have another option. Whether you agree or disagree with this option, you do have an option to go with an outlet type, and it is going to protect everything that's installed downstream from that existing branch circuit. Okay, so this is all hinged on an existing branch circuit, not one that you rip out and replace. Okay, this is for the existing, okay, to the first receptacle of an existing. So if you're extending it or modifying beyond that point, okay, that's an option. Now you have an exception. The exception says, okay, well, look, all right, AFCI protection shall not be required where the extension of an existing conductor is not more than 6 feet and does not include any additional outlets or devices. So this rule came in to allow me to be able to say, do a panel change. Sometimes I had a panel that may be in a location that when I'm doing a remodel, it can't be in that location. So let's say I have a panel that's aiming in a certain direction, it's in a bathroom, but now we're going to remodel this bathroom or this area that's going to become a bathroom, and you can't have these in there. So now I want to move the panel, or maybe I'm putting cabinets up or redoing it and I need to move it. And I have moved the panel. As long as I move the panel not more than 6 feet, and those branch circuits are not going to be extended more than 6 feet, this is allowing me to be able to do that without kicking in this requirement for AFCI protection on those branch circuits that are being modified. So this would allow me up to 6 feet of movement to be able to do this. Now, this doesn't just apply to that example with a panel. It is anywhere that I might have to move, but it doesn't move more than 6 feet. Then as long as I don't add any additional outlets or devices to this, I'm simply just moving it, okay, to this branch circuit. Okay, I'm not modifying it in that way. Then I can move it. I can shuffle it around. If I'm just moving a panel, but I'm not extending this branch circuit by adding additional outlets on this circuit, then I don't need the AFCI protection. Okay, it was okay at the time it was installed. It's okay now. There's no sense in kicking it in. I think a lot of AHJs want to trigger that and say, well, you move the panel. Well, in theory, you're extending these branch circuits because you might be using the existing panel to extend over to the new panel. And again, as long as it's not more than 6 feet, then you have this exception that's going to allow that. If I'm having to remove a receptacle due to remodeling and I'm moving it, say, this way or that way, but I'm not adding any extension onto that, then no harm, no foul. I just simply are moving it. Okay. I know a lot of times as inspectors we want to impose our will on something because we think it makes something safer. Reality is this is a minimum safety standard, and you can't just be onerous on the installer and make them do things that are not governed within the NEC. That's a minimum standard. Now, if they want to, out of the goodness of their own being, want to protect it all and do that, that's great. All right, but we have to follow the rules in the code. So in this case here, I do have an exception, and it's not required on where the extension of the existing conductors is not more than 6 feet and does not include any additional outlets or devices, okay, on that branch circuit. All right. So this is great for a panel change where you're moving the panel. A panel upgrade doesn't necessarily going to constitute a change in AFCI on all these circuits because you're not extending them more than 6 feet. You're just changing out the panel. I've had a lot of people call me and tell me in a panel change they make them upgrade everything to AFCI. That's what this exception is all about. Okay, you don't have to do that. Okay, maybe it's a good choice to do it, but you can't make them do it. Okay. Anyway, there you go. That's explanation of all of the items in 210.12. Hopefully, I made it a little clearer to you. That you can understand all these rules and changes. Again, as always, if you have any questions on any of them individually, please feel free to give us a call. But most importantly, you can call me at 540-607-0116. More than happy to discuss anything in here that help you understand the code a little better. Also, you can email us at info@masterthenec.com or info@electricalcodeacademy.com. Visit our websites, visit our message boards, visit our YouTube channel. We post a lot of things on there, all those type of goodies. So thanks again for listening. Hopefully I explained the allowances of 210.12 a little better for you. And then it'll make your installation a lot safer. You'll be a lot more informed, and everybody will learn a little bit more about the location requirements for AFCI devices. Thanks again. Have a wonderful day.
Every day, the future's getting closer. Every day, the future's looking bright. Every day is another beginning.